Welcome to C++ for Java programmers. I'm Professor Caliph. In this video, I want to talk about functions in C++ and how they differ from those in Java. The first difference is simply that C++ functions don't have to be in a class. I've mentioned that main can't be part of a class. We can also have other functions that aren't methods. We typically write any functions that operate only on their parameters outside classes. So the math library in C++ is not a class full of static methods. It's just a collection of functions. The next thing we need to know about C++ functions is that order matters. In Java, the order of functions in our file doesn't matter to the compiler, but in C++, we are only allowed to call functions if there's a declaration of that function earlier in this file. The purpose of the include of IOStream in our previous video was to put the declarations of all of the IOStream functions and other needed information into our program file before we tried to use it. We have two ways to provide the function declaration. The first, and generally preferred approach, is to put a function prototype at the top of the file. We can think of the prototype as a function declaration. Notice that it is very similar to the declaration of an abstract method in Java. Technically speaking, the parameter names, so the subtotal here, is optional in a prototype, but they are highly recommended. The second approach to solving our problem is simply to reorder our functions so that the functions that don't call others are at the top of the file and main is at the bottom of the file. This certainly works, but it's not generally recommended. These days, people usually expect to see main first, and other functions that accomplish a lot, typically by calling other functions, higher up in the file, with the littler functions that actually get the work done toward the bottom. Let's actually take a look at this in code. Okay, so let's pull up, let's create something, let's call it funcpractice.cpp. Okay, we'll do a quick top of the file comment. Functions. Okay, I'm going to assume that I'm going to need to print something at some point so we can demonstrate what we're doing. So we'll go ahead and include IOStream and use namespace standard. And let's start out by just writing main. I'm going to go ahead and leave out the command line argument stuff at this point. And I'm going to write a very simple function that just computes sales tax. So we'll call that compute tax. It will take in a subtotal and let's go ahead and create a constant. As in Java, constants are typically done in all caps with underscores separating the words. And let's assume that we're in a 0.75 kind of a world. So then we will return subtotal times sales tax. And here, we go ahead and create a subtotal. I'm just going to set it to 10. Then let's call, actually, let's just say double total is subtotal plus compute tax subtotal. Let's try to actually compile this. So I want to demonstrate to you that issue. So let's compile funcpractice.cpp. I thought I saved it. Apparently I imagined saving it. Let's try that again. And save and get to the error we want, which is compute tax. This function was not declared in this scope. So in C++, you have to always have it before. So of course, as we said, one option would be to simply take this and move it up above our main. And if we do that, that will fix our problem and we will be able to run our program. Except it won't print anything because I didn't have it print anything. So let's real quickly come in here and just say cout total Okay, so we can see that worked. It worked fine. We could compile. However, as I said, we typically don't want to do that way. So what we typically want to do is right after all our includes, we want to have a set of prototypes. And so the prototype here will simply look like compute tax double subtotal, but then it won't include the body of the function. It's just a declaration. Now, for a very simple function like this, that feels kind of silly to do. But remember that not all of our functions only have one line. And even when they do, this allows us to group all these declarations together and then put the actual implementations at the bottom of the file, sort of tucked out of the way. Of course, we ought to have some sort of variable, so function that computes sales tax on the subtotal. And then we can move this back down to where it belongs, after main. And let's try it out this way. And you can see that that also works just fine. Now, a couple of things to note. We don't actually have to have the name of the parameter here. So if I compile that, it will still work just fine. Now, it's recommended to have the parameter there, because if you don't have the parameter there and you have multiple values, especially if they're all the same type, or there are multiples of the same type, it can be very hard to figure out which one's supposed to be which. This is where people should be going to see how to use your function. And this is where experienced C++ programmers will be going to see how to use your function. So do yourself a favor and put in a meaningful parameter name right there. Okay, let's flip back over. So I'm going to pull these out of the way and want to talk to you a little bit about my recommendations for function prototypes. The first and possibly most important recommendation is use them. This is the standard way to do things in C++. It's not what you're used to in Java, but that's okay. You're in C++ now. So if you're writing a single file program, all of your functions except main should have prototypes at the top of the file. We'll talk later about where prototypes might go in other circumstances. Next, provide parameter names in your prototypes. As I mentioned, they're not required for the computer, But this is one of the places where you should be considering both of your audiences. You need to pay attention to the human programmers who'll be looking at your code, including you in a couple of years, when you have no idea what you were thinking or why you were thinking it when you wrote this code. Names of parameters can be really helpful in figuring out how to use the function, and that leads us to my third recommendation. Always provide a brief comment explaining the purpose or use of your function. In general, people aren't going to go look at the full function definition to see how to use your code, and they shouldn't have to. It's okay if you don't have a lot of commenting and explanation there about anything except something interesting about the code that people should understand. You need to give enough information on the function prototype to allow someone to call your function successfully. Okay, let's take a look now at function parameters. By default, C++ parameters are passed by value, which of course is how Java passes parameters as well. So in that case, we're just going to copy the data from the caller into the local parameter, and any changes that we make won't be reflected in the original. However, C++ provides us with an option for something called pass by reference. To use it, we're going to include an ampersand between the type and the parameter name, just as you see here. In pass by reference, we're going to send the address of the variable to the function, and each time we reference the parameter in the function, we're going to follow that address back to the original variable that was passed into the parameter. So any changes we make to the parameter are reflected in the original. This can be very convenient for updating values or returning multiple values from a function. Note that it is not recommended to both return values and pass other values back via pass by reference from a function in most cases. The one exception would be reporting success or failure. So for instance, if we're doing a search, we might return true or false, did the search work, but return the actual result of the search in a pass by reference parameter. As we pass around parameters, sometimes we want to use pass by reference, not because we want to change the parameter, but because the parameter is big enough that we don't want to copy it. In C++, we're going to discover that our objects don't have to be dynamically allocated, and sometimes we pass objects as parameters where pass by value could be very expensive. However, even though we're passing things by reference, we may not want to allow them to be modified. This brings us to our second use of the keyword const. When we have parameters that could otherwise be modified, either because they were passed by reference or because they were arrays, where we're normally able to change their contents when they're a parameter, we can add the keyword const before the parameter type to specify that it won't change. So here's an example of that. I've passed this input param by reference, so it could be modifiable, but I've included this keyword const. When we do that, the compiler won't allow us to modify the parameter in the function in any way. We can't assign into it, we can't pass it as a parameter to another function unless it's a const parameter to that function. It's basically a way to tell the compiler, hey, make sure I don't accidentally change this. The last aspect of function parameters in C++ that I want to mention before we take a look at this in actual small program is default arguments. C++ allows us to specify a default value for a parameter. When we do that, we then don't have to provide that parameter with an argument unless we want a different value. So here we have a default tax rate of 7.5%. When we want to use that rate, we don't need to provide the parameter. We can just give it the subtotal. It will use tax rate as the 7.5% that we specified in the default. On the other hand, if I want to use a different value for some reason, I can still pass the parameter with the value I actually need. Two important notes about default arguments. First, the arguments are always left out from right to left. So if you have one default argument, it must be your last parameter in order to work. If you have multiple default arguments, you'll want to put a little thought as far as which argument people are most likely to want to leave out. And consider that if they leave out any, they have to leave out the last one. Second, we only specify the default value for a parameter one time. You'll get an error if you put the default value on both the prototype and the header of the full function definition. It's generally considered better to put the default argument in the prototype, since that's where people are going to go to find out that you have a default and what that value is. Okay, so let's head back into Unix and try out some of our, Linux. Try out some of our parameter capabilities. So first of all, I'm going to play with the default argument thing just a minute, let you see how that works. So let's go ahead and add, actually, let's move this constant so that it is above our function prototypes, since I do want to use it in them. So now I'm going to have a double tax rate that is sales tax. And then we're going to modify this so that instead of using that sales tax, it's going to use tax rate. And of course, we need to also specify that parameter here, but we won't put in the value. Let me show you what happens if I do put in the value, even though it's the same value. If we try to compile this, we're going to see previous specification here. So it's letting you know, hey, you're not allowed to do this twice. So if we take out that second specification, let's go ahead and see what happens here. You can see it compiles, and it works, and it gets exactly the same result as before. Now, what I'm going to do is to say double total 2 is subtotal plus compute tax subtotal, and then go ahead and pass it a value. So I'm going to actually make that 6%. And let's print the other one. Because I know I should. I'm going to switch this to just \n. And let's compile that and run it. And you can see that in the first one, it used the default argument, and we got the 10.75, whereas in the second call, it used the argument we specified, and we got the 10.6. So this is a really convenient capability. I hope you can see the possibilities that this provides you. Okay, now I want to look just a little bit at this whole pass by reference thing. So let's go ahead. First of all, let's modify this so that it is providing both the tax and the total. So I'm going to make this a void function. I'm going to have a double ampersand, so I'm passing by reference, tax, and a double ampersand total. Now, then I'm going to need variables to get these things. So tax and double total. Let's actually get rid of this. I'm going to say tax, and then we're going to modify this so that instead of returning that, it is, first of all, getting these variables. Then we're going to say tax gets subtotal times tax rate, and then total gets subtotal plus tax. Then we won't actually return anything. This is now void. And let's see what happens. So let's actually set values for these so we can see that they have changed. So I'm just going to set them both to 0, 0. Okay. And let's compile and run. And call the method. Subtotal tax total. And we can see that both of them were modified. So that's great. Now I want to kind of show you what happens if I put a const on one of these, just so you see that it can't be changed. So I'm going to put const on the tax, but we're trying to assign into the tax. So when I try to compile this, I will get an error, assignment of read-only reference tax. And so that's what const is doing for us. If I try to use that in a way that's going to change its value, then I'll get an error. And we'll see places later on as we see some of the bigger items where that matters. So that gives you a little bit of an idea, hopefully, of how default arguments work, how pass by reference is done. So let's flip back over. Thanks for watching. In the next video, I'll be talking about arrays in C++.